mathematical practices, I did not do it. I just would not do it. Because they were going to learn the error of their ways in a year or two, and they were going to say, oh, we've rethought things. We've rethought these insane pacing plans that had us teaching things in 1 day and 2 days that should have taken a week or two. So, and they would have come back, and without apologizing to that whole group of students whom they had harmed, they were going to say, well, we thought about things and we've changed things, so I just didn't do it because I thought it was actually criminal. But the Common Core standards for mathematics and for English and language arts are actually something that I can embrace. So I'm happy that the district is actually moving in a way that is positive for our students. We're going to talk about two things today. We're going to talk. You're going to be given a math challenge. The way it's going to work is I'm going to pass it out to you, and you're going to work on it for, let's say, 3 to 5 minutes on your own. Just time to think and do things on your own, and then you're going to be able to talk to the people around you and compare strategies and talk about how you can figure this thing out, this challenge out. And then we're going to be talking in a whole group about things. And then we're going to be talking about our talking. There are standards for mathematical practice. There are 8 of them. And I happen to think they are truly wonderful. They're separate from the mathematical content standards. And they're standards for mathematical practices. How do you become a good mathematician? And I think those particular standards, many of them, have carryover to other content areas. So you're going to get a copy of the 8, and on the flip side, we're going to go into a little more detail about 2 of them. The 2 that I think are the easiest accessed and the most transformational. So that's what we're going to do. And of course, afterwards, you can ask me any questions. And I promise if I don't know the answer, I'll tell you I don't know the answer. And I'll get you the answer. So, let's begin. 2, 3, 4, perfect. Thank you. Yes, and I'm also going to get some pencils. Actually, you can pass them down to these as well. And now, if you have a pen, that's great. If you don't have a pen, please raise your hand and I would be glad to furnish you with a writing utensil. Raise your hand if you'd like a writing utensil. Now remember, you're working by yourself. Arr.
What grade level is this?
This originally is from 6th grade. Well, I hate going to adults. I hate going to adults and saying to adults, pretend you're a 1st grader. I mean, I purposefully chose something that may be a little challenging for some of you. And because I want you to be in the position that the kids are in. I want you to have that struggle. This is not first grade. Hi guys. Guys, if you think that speaking with one another will help you, then we don't have to take the full 5 minutes. Really like the way that I see some people identifying the right angles. Those are the ones that look like steps, the kind that you would like to have your stairs made in accordance with. That means a step up and a straight line across. Those angles are 90 degrees.
I just remembered John.
Dorothy's cheating. Dorothy's cheating. Dorothy's cheating.
No, I say you can collaborate. You can collaborate with people. You can collaborate with people, and if somebody wants to get you started, you can collaborate. Did you know that any triangle has an internal total measurement of angles of 180 degrees. Not on the three-dimensional surface, two-dimensional. We're talking two-dimensional. So the internal angles of a triangle will always add up to 180. The internal angles of a square will always, or a rectangle, will always, on a two-dimensional surface, will always add up to 360. And the angle of a straight line is always equal to 180. When you say somebody did a complete turnaround, you say they did a 180. Okay, so now take that new and valuable information and go forth and conquer this problem. I really like the way people are attending to this problem. You're investing your time and your energy in solving this problem.
Oh, because of this. Where I am, I have to do that.
You are welcome to eavesdrop. You are welcome to eavesdrop. If you think the next group over might have a good idea, then go ahead.
How about asking the teacher?
Lean in and eavesdrop.
Very proactive. Teacher, I don't know.
Which means that it's well, the whole thing is go on right now.
Yes, but I'm going to give you these in case when you have to leave, you have the mathematical standards listed. You have them going into some detail, and then you have two of them going into even more detail. Okay? This is from I don't have enough energy to go and research all of it, so I research just take yourself. But that's not me. Yeah, that's okay, now I will tell you that we had some people, we had at least one person who, when I was doing the first walk around, had solved everything.
Wow. Who's that?
I will tell you.
Who's that person? No names, no names.
I will tell you that a lot of people are finding that when they put their heads together, that really helps. Raise your hand if putting your heads together really helps figure it out.
Putting one head together.
Okay, so you have some people who would rather work alone, who got a chance to do so, and you have some people who really benefited from working with other people. And then when you were in the midst of struggling and grappling and wrestling with this Herculean problem, I just threw in a little bit of information that really you were able to apply immediately, right?
Yeah.
And so you were thirsty for it, and so you actually used it. If I had just said, boys and girls, the internal angles of a triangle equal up to 180, and then do the problem, it wouldn't have made the sense that it made to you because you wouldn't have been able to take it and apply it immediately. So it was done on purpose. I wanted you to struggle a little. And I wanted you to struggle and then talk about it with each other, because students can, number one, peer tutor. Let's say I have one of the pieces of information that will get us there, and you have another. And let's say mine needs to be done first. So I feed you my information, we do a little bit of work, then you have something to add, and we can get further. So this mirrors a classroom. I wanted you, and for most of you, it was a little bit of a struggle. It was a little bit of a challenge, or a lot. And there is no person who is not a math person. I always think, on the first day as a teacher, I would write Yoka on the board, E-O-Y-K-H. And I said, math is that. Everybody say that word, Yoka. And it's E-O-Y-K-H is easy once you know how. Math is easy once you know how. Once you're taught, it's easy. There's no magic. There's no mystery. So to desensitize ourselves, but here's what I'll tell you. When mom or dad is math phobic, even if they're trying to be supportive of their child, if their child knows that mom or dad is math phobic, you're modeling that for them. Because they seek to emulate you in so many ways that if you say, oh, get some help from somebody else because I'm not a math person, then they automatically think it's very acceptable to adopt that same position, that same stance. Don't talk to me about math because I'm not a math person. So would you ever say that about reading? Don't talk to me about reading because I'm not a reading person. So, but you feel okay to say it about math. So sometimes when we love a person, that means we have to face our own crap and push through our own crap because we love that person enough to do that. We know that inadvertently we are putting an impediment in their way. So I ask you to think about that, if that fits you, and if it does fit you, stop it. Think about ways that you can be more of a math person to model that for your child. I've always been challenged by math, but you know what? I like a challenge, and I'm going to stick with it, and I'm going to learn. So I encourage you to do that. Now, we've established that some people liked working alone, some people got a lot out of working with other people. How did working with other people help you? How did those conversations help you for those who did not do it right away?
It actually helped me maybe think and maybe brought my perspective on I put that paper kind of foreign language to me. But when she started asking me to do certain things, we were able to start to connect. And I was like, oh wow, okay. If I just took my time and figured it out, I can figure it out instead of just saying, oh, I can't do it. I'm one of those parents where I really said, well, talk to me about math, so thank you.
You're welcome.
Yeah, so it was help.
Good. Anybody else? Anybody else get helped by talking with people about it? And if so, please share out.
Well, I'm not a math person. I really was lost. And if it wasn't George, I wouldn't have had a clue what I was doing. And he explained it. And, in a way I could really grasp. And I don't know, I guess I feel that if here was, is telling me, giving me some guidance, a little bit different than if I was standing over my son.
Excellently, and I loved what you said so much. I can't wait to jump on it, but I'm not going to because I saw another hand up and I want this to keep going.
Oh, I was just going to say that, ever since
me ask you, when you got the pieces that were missing in your knowledge base, do you understand those concepts a little bit more now? Okay. What I love about what you both said is that when they approached the members of the team that wrote the map on Common Core Standards, Phil Darrow was one of the primary authors, and he's of retirement age, and he was thinking to himself, this is not what I want to be doing at this point in my life. And the governor's conference came to him and said, would you be interested? We want standards that are national. Would you be interested? He said, well, let me ask you a question. Are we just getting everybody on the same page about standards, or are we going to the next level? And they said, well, what do you mean by that? And he said, we have had 30 years of standards and 30 years of high accounts testing, high stakes testing, and it has not been servicing our children. We are still not in the top 10 countries in the world as far as mathematics and performance. So are you just talking about getting everybody to agree on one set of standards, or are we going to go beyond that and really try to address the pitfalls that we have encountered in the last 30 years? And they said, well, we'll get back to you on that. And he thought that was the last time he was going to hear from them. But they came back to him and he said, we want to take the next step. So one of the main things that is involved in the next step is that math instruction in the United States is, you know, a mile wide and an inch deep. And that teachers have to cover the standards. And if you've seen the California standards for mathematics, which this is replacing, you see this voluminous kitchen sink with everything piled in. And when they wrote those standards, everybody brought everything they had to the table, and they didn't wheedle it down. They didn't pare it down. They just included everything. And their idea was that if you spiral through it every year, everything, that it would little by little make sense to you. And these are educators. How does that make sense? How does that make sense that if I present something to you so inadequate and in such a brush-by way, a drive-by way, that if you get that drive-by 6 years in a row with lots of things in between, that it's going to catch on little by little? They have to get the needle out of their arms, right? They have to say, this is not the way we educate. So the Common Core Standards, in order to not be a mile wide and an inch deep, they had to cut down the standards that they were addressing so that they could go deeper. There are countries, primarily Asian countries, who go deeper with fewer standards. I think the typical textbook in the United States for, let's say, middle school or high school math is 922 pages. The same corresponding math book in, let's say, Singapore or Japan is 140 pages. But there's more mathematics in that 140 pages than there are in the 922 pages. Because they focus on the mathematics and not on the lesson. It's a big, complicated mess, because what they wanted teachers to do was to not plan individually. They wanted to give the teachers a teacher's edition and say, here, teach this page by page. What does that do to the teacher's planning? Why should I plan? Why should I spend all that time planning when they just want me to follow this teacher's edition? Teachers at this school have been more independent than that. And that's a good thing because they're more in the habit of planning. So we just need to focus their planning to make it as valuable as we can. But now they're coming back around and asking teachers to think of the mathematics. So, I would like to, and would you please help me pass this out? Arr. Oh, I think that's syrup or something. If there aren't enough, I will go immediately and get copies made. What I'm passing out now are the standards for mathematical practice. It's kind of a discussion of, and I'm missing, you have yours, but I'm missing 2 more on this row.
We can share.
Actually, here. That's for you. That's for you, Molly. This is for you. Now, thank God, because when I took the principal's test, I forgot my glasses that day. So thank God, I'm going to hand you out something that has them in a lot larger print. So, let's look at number 1. You don't have? Okay. Now I'm going to have to force
Well, no, I
myself.
have hers. No, I think she has some there.
She has.
There's another stack there.
Oh no, actually that's okay. We're not going to pass those out quite yet. We're just going to read them. Number 1, make sense and persevere in solving complex problems. Is that a very commonsensical approach to mathematics? Make sense of and persevere in solving problems. Complex problems. Common sense, right? Does that apply to science? Or reading comprehension? So that is a practice that if we explicitly put intention into teaching our children, that will have many, many, many benefits for them, correct? In their lives, inside school and outside of school. So good for them. Number 2, reason abstractly and quantitatively, to be able to go back and forth. Let's look at the numbers, but let's look at the concept as well. And how does the concept interact with this individual challenge I have? Number 3, construct viable arguments and critique the reasoning of others. Isn't this the crux of what education should be? To be able to construct viable arguments and critique the reasoning of others? For me to be able to construct a viable argument, I have to make sure that I have clarified the points that I need to clarify, have applied my own logic to it, and to be able to construct a viable argument. And then to listen to others and to be able to critique the reasoning of others. This applies in every aspect of our lives. This is a righteous, wonderful, like it's the tzaddik of these standards. It's a holy standard for education. This is what education is. Number 4, model with mathematics. Number 5, use appropriate tools strategically. So knowing when a calculator is needed, knowing when you need to use the centimeter side of a ruler or the inch side, knowing how to use your tools. Attend to precision, number 6. Attend to precision. They say that the point of a math lesson is not the right answer. Rather, the right answer is a byproduct of the intended focus of the lesson. So the intended focus of the lesson is mathematical reasoning. Our children thinking their way through a challenge. Some people will get the right answer and not really know how they got it. They can't explain it. They don't know. The teacher told me to follow these steps. I followed them. I got the right answer. And for too long, we've been doing too many math problems and just focusing on the right answer. What if we focused on the mathematical reasoning? What if a lot more student voices were held in importance? let's say Cheryl is not the most facile math person. Let's say that. A lot of times, American teachers will just call on Cheryl, she didn't get the right answer, and call on somebody else. When, let's say, the Japanese teachers see Cheryl as the canary in the mine, they say that her reasoning represents the reasoning of quite a few students. And so to have her stand up and share her reasoning, and then say, let's look at the reasoning. Let's look at her reasoning. Let's kind of analyze it and see where it falls apart. So that number one, the affective filter, the anxiety level in that classroom about making mistakes automatically goes down to the basement, because we are in a lab where we are all working on our own knowledge base, where it is fine to be at whatever point you are. And that takes purposeful teaching. You know I'm nice most of the time, but I am not nice when people make fun of other people. And as a teacher, I made that very clear. None of us is perfect at everything. All of us have our strengths and our weaknesses. So it has to be safe for us to come at whatever point we are to this process. So let's say Cheryl solves a 6th grade problem using 2nd grade math. She's solving the problem, but she's using 2nd grade math. Let's say that Tamar is using 4th grade math to solve a 6th grade problem. And let's say that Stacy is using 6th grade math. If I let Cheryl share out, and she's so proud because she solved the problem, this is what I did, and she explains herself, and then Tamar shares out, and I say to Cheryl, does that make more sense? So Tamar is actually teaching us her reasoning so that we understand. And then Stacy gets up, and I say to Cheryl and Tamar, can you see how that works? And this is what I'd like everybody to try. I'd like everybody to try that one. Whereas too many times in American classrooms, whatever way you got that right answer, the right answer was the point, and the mathematical reasoning wasn't. So 2nd grade math used to solve a 6th grade problem ends up being acceptable. Whatever you use to get there. So the product becomes more important than the process, and that's what we're changing.
Can I ask you a question?
Of course.
But like, for example, when my older son was in his Phoenix class, he was sort of big on like, I don't care which method we use as long as you get to the right answer. And I kind of appreciated that because I think different kids have different wiring and different methods might work. And that doesn't necessarily mean there was no reasoning behind it, but is there any room within the Common Core for individual minds with their own problem-solving abilities to work in different ways?
Yes and no. You know, it's always going to be a complex answer, okay? So let's take the first part of your sentence.
Yeah.
It always has to be okay in an instructional setting that people get to the answer in different ways. Always. But within that umbrella, when you see children using 2nd grade math to solve a 6th grade problem, or 4th grade, then you say, I can furnish them, I can provide them with something better. Now if they have a completely different way of doing it, that is also welcome. But we're talking about getting the best reasoning, the best quality of reasoning into that classroom. Everything is accepted, everything is embraced, and then the teaching begins. Let's take you from where you are, and let's give you some more mathematical knowledge. And then it's up to you to solve things how you will. But to give them access and exposure to the highest quality mathematical reasoning.
Because those of us that have had, a few kids going through and like different mathematical teaching over the years, we're seeing the same thing taught in different ways. Like right now, I have a 3rd grader who's being taught division in a way that I think is kind of, weird and not that great. And like, the answer is the same, but the method by which they're supposed to solve the problem seems counterintuitive. So I wonder about that part of it.
Okay, so if the answer is not the point, oh, I'm sorry.
Oh, I'm just saying that, over the years, as you watch your kids go through the same grade level and the same lessons, and they're taught how to solve the same problem in different ways, and some of them seem overly complicated, not creating an efficiency in problem solving, let's say. I'm just a little concerned that we're layering in like a new
Okay,
way of telling kids
the
what to do.
not simple answer to that is that it all depends on the mathematics that is being taught in that lesson. Sometimes people, if the right answer is the point, then they may get little tricks to get you to the right answer, as opposed to focusing on the mathematics to get you to the right answer. For instance, ours is not to ask why, just invert and multiply. You remember that?
Absolutely.
Okay, so you don't have to know what you're doing. I'm going to just teach you this trick, and it's going to give you the right answer. You don't have to understand it. In fact, I implore you, don't question me. So, that kind of reasoning, in cases where it truly is a counterintuitive, subpar level of mathematical reasoning, we are going to be in the process of replacing that with focusing on the best mathematical reasoning. Mathematical reasoning that ties together number sense, brings number sense into fractions and decimals, and then in a continuous line heads on to algebra. Sometimes the way we teach fractions and decimals is counterproductive to then later teaching algebra. We want to make the mathematical reasoning sound. That's what we're going to be focusing on. So some of those things that you think might be counterintuitive might turn out to be counterintuitive, and we might not continue those practices, and we will be examining our practices in the light of the math behind them. Okay?
My husband happened to come from a math family, they're all PhD in math. And whenever I teach my second grader in math, he gets more frustrated. Just the same reasoning as in school. But when he's teaching it his way, which is not our school's way, a lot simpler, and somehow he gets it, my kid gets a lot more out of it.
Can I touch your husband, please?
Came from Princeton too. But so the question I have, is that matter as long as he gets the final answer and understands the concept of it? Because I find it our
Okay,
way is
but
a lot longer, like the way we explain things.
You put two things in the sentence that don't necessarily belong. You said as long as he gets the final answer and the concept of it. So how about the concept of it is most important, and if he knows the concept, he'll get the answer. It's a byproduct and not the product. So the concept is the most important thing. And if your husband explains things in a simpler way where the conceptual mathematical reasoning is there, bravo. That's why I want to talk to him. So another thing about the way textbooks are written in the United States is they have different interest groups. Like committees will buy wholesale lots of books from these publishers. So if we have some things in this book that this committee is going to like, some that this committee is going to like, something for this, something for everyone, does that service our children?
No.
Because what you end up having is a whole lot of disjointed, convoluted math instruction. All to sell more books to more people.
Right.
So we're going to have to go in the opposite direction, and we will go in the opposite direction. We have a 2-year span combined, very small, Common Core budget, and I've spent 14% of it, 14 2/7% of it, which is 1/7 of that on math material by a woman named Kathy Fosno, and she didn't jump on, the number of emails that I get, Common Core this, Common Core that. The number of emails that I get trying to sell me Common Core is a lot of money, let's do it. Kathy Fosnos is part of the base on which Common Core core standards were written. So she has a very foundationally based approach to mathematics instruction. I bought everything that we could want for a number of years of developing our own capacity to teach mathematics, because my priority is to affect the teachers. The teachers are our greatest investment, because who's in the classroom with your child? It's the teacher. They can have the best materials in the world, but if they are not knowledgeable and well-founded, steeped in good instructional principles, the best materials in the world aren't going to help your students very much. So what we have to do is segue away from the teacher's edition model to the mathematical reasoning model. And so we are going to start, when we get the materials, which is hopefully next month, we're going to start with a 10-minute segment at the beginning of every math period called the number stream. And it's a series of problems that kind of step by step take the student's understanding inch by inch towards a goal. And most of that 10 minutes will be involved with students sharing their thinking. So that's a very bite-sized, doable, concrete step. That 10 minutes is going to be sacrosanct. That 10 minutes has to be done in this way. I'm going to be looking. And you know that all of our teachers, in their hearts, want what's best for their students, and I believe that they will embrace this. So our job as a school is to transform our teaching. And as a teacher, I never ever, and I was a good teacher. And I think that teaching is one of the most important jobs you can have in the world, because you change people's lives. You really change people's lives. So our teachers don't feel like they're complete. They don't feel like they're done growing. And if they do, I have a few words to say. But we are going to have to grow. We are going to have to build our own capacity. Okay?
I think the teachers, this is a challenge for them because it's a new way. So will they get like additional support on this, and like how can we as parents help support them?
Well, they will get additional support in buying these mathematical materials. I got a promise from somebody in the district who's very excited and a math person that she will come and give us professional development based on these. So, and we are going to be devoting our professional development every Tuesday to moving forward in English, language arts, science, math, and social studies. So our teaching, if you focus very deeply, not an inch, mile wide, an inch deep, but if we focus very, very in-depthly on our teaching of math, it's going to spill over into all subject areas, and likewise when we go deep into English language arts. Because all of our minds are pattern seekers and pattern detectors, all of ours. And when you have a concept, when you understand a concept, automatically you apply it to different situations, right? So our teachers, as our teaching gets better in any individual subject, it will get better in all subjects. When you want to listen to the kids' reasoning in math, all of a sudden it's science time and you have no interest in the kids' reasoning in science. So everything is connected. The quality of our instruction as it gets better is going to get better across the board.
Just jumping off what you're saying about connectedness and everything, now that I have a middle schooler and I see how screwy the math instruction gets in 6th grade, with the jumping from thing to thing, I think they were doing fractions to interest rates to decimals, it's all over the place and it's crazy. But what I understand from the middle schools is that they're no longer going to be doing algebra, geometry, algebra 2,
They are restructuring.
Right, so can you kind of give us the big overview of what happens in elementary, the new
I can't give you what happens in elementary as opposed to middle school, because I can only fit so many things into my brain, and so I limit myself myself to where I have,
I mean, it seems
where
like
I'm
a huge
involved.
systemic shift in
But
the whole
yes,
12 years.
what we're doing for elementary school is we're shifting a lot more to having a really good, strong foundation in number sense. Like grades 1 and 2, so heavy into number sense, and grades K and 1, and then 2 and 3 still with number sense. What happened in the past is we got too quickly to the paper and pencil. And then once you have abstracted the idea of numbers, once you have lost your opportunity to know that numbers have a one-to-one correspondence, they stand for things. 3 stands for 3 eggs, or 3 chickens, or 3 bulldozers. Once you lose that, then it's harder to get the conceptual ideas that are built upon them. So what's happened in the past is we've gone too quickly, and even kindergarten, to let's do these problems on this page, and not enough with working with objects. The same with the idea of base 10 and base 5. Base 5 is a relatively new concept, but we all know base 10, right? The decimal, that everything is based on groups of 10. I've taught kids where they didn't know that 38 was 3 groups of 10 and 8 left over. So you have to take it back. You have to take all of this instruction back and put it where it belongs. First, give them a very strong foundation, concrete foundation. Let's put base 10 blocks together to make a 10 stick. And know that that is a unit now. Whereas 8 is not a unit. 10 is a unit, 100 is a unit. Let's do that and have them build things. Build the numbers. Race to 100. Race backwards from 100. Give them that foundation, and then when they go to the paper and pencil, they know that it stands for something. I know that one of the parents here said that she had a really hard time with multiplication in 3rd grade. The other kids were getting it, and she still wasn't getting it, and she still wasn't getting it, and her kind teacher, maybe Miss Steinbeck, I'm not sure, but her kind teacher sat down with her, and with some manipulatives in 3rd grade, and said 3 times 3, well, and she put 3, and she put 3, and she put 3, and 3 times 3 means that you have 3, and you have it 3 separate times. And the child could see that. And all of a sudden, it made sense. When it was just memorization with no meaning, they were just abstract numbers. They were arbitrary numbers. There was no pattern that her mind could detect. And then when you give a child the anchoring in concrete understanding, they will make up lost time, they will shoot forth, because their minds are so smart. We have what it takes, but we need to give them the anchoring that they need. And then, from that point on, she was fine.
Is this new concept, is it evidence-based practice that has proven that this new way is actually better than the old way?
Yes. Simple answer.
By whom?
Okay, so I can't give all is this evidence-based that these practices really work? Finally, I give a simple answer, yes. And she said, how is that proven? So, I can't cite the studies, I can't give you the countries, but there are always these, I think, 18 countries or 14 countries that always are at the top. And so we study and they're based on a test that's given every 5 years to sampling throughout the countries. And so America thinks, oh, if we want to do well on that test, we've got to cover everything that's covered on the test. So we covered upwards of 80%. And we are still near the bottom.
Yeah.
The countries that covered 40% of the math that was on that test, but really set the foundation, were the countries that were at the top 14. So they taught less, but they taught it deeper, and they focused on the thinking. And not only that, but there was another country, I think Canada, said, okay, let's just do it. Let's just do what they're doing.
Numbers went up.
They went up to the top 15. They went up right to where those people were. So, all I can say is that it makes sense to me as an educator that you don't try to throw everything at them, but that you focus on a narrower, deeper understanding.
Right.
It makes sense to you. It's common sense.
Yeah.
And finally, we're doing something like that.
Can you say something about the testing that's going to start this year?
Yes, I will be doing a coffee talk on the 27th of March about the Smarter Balanced assessment. Did you hear the question?
Yeah, I'm
Oh,
gonna
okay.
have to.
That is going to be a field test. We are going to have a partial test in mathematics and a partial test in English language arts that the students will be taking online.
All grades
3rd grade, 4th grade, and 5th grade
this year.
this year. And the results will not count, but they will count next year. And we anticipate there being a lot of bugs, a lot of malfunctions, a lot of problems, but that's part of the reason why it doesn't count for this year. And more information in 1 month.
Wait, will we know the results of the test, of the field test?
We're still in negotiations as a district. We have to buy the results of the test. We have to buy the test.
And the test will cover the Common Core standards? Or
Yes, they're aligned to Common Core standards. And then we would have to buy the results.
So the teachers are currently teaching in fixed now.
A mixture.
Huh?
A
The old
mixture.
ways and the new ways, right?
The old way and the new way. It's a mixture. It's kind of a mixture year. And it will be a mixture until we really get this paradigm shift. I don't know who raised their hand first.
How will they take the test online?
In the computer lab or on a cart that is supposed to be delivered to our school only for testing purposes. A cart of 35 iPads that you can do nothing else with except for test, and they will be picked up afterwards.
In the past, I know there was a lot of like teaching to the test and preparing the kids for the CSTs, and now that it's all changing. How does the new test, how is it in line with Common Core? And I'm hearing from my older child that they're kind of skipping around lessons because the teacher wants to focus on what the test will cover.
Well, it's not exactly that. The math curriculum is being rearranged because we're not covering the same things in the same grades. So if your perception is that the teacher is skipping around, maybe it's because the Common Core standards for that grade level don't include everything. And so the teacher has to skip around.
Right.
And as far as teaching to the test, remember when I said that America wanted to do better on that worldwide test, we included everything? Well, that's kind of what teaching to the test is like. You're trying to cover everything and you don't get very far with that. So if you stick, I would advise you to have a conversation with your teacher. If you repeatedly think that the homework is esoteric and you don't understand the connection, and have a conversation with your teacher. And then always, just as I would not like you to go to my boss before coming to me to speak to me, I want you to come to me first if you have a problem with me. If you have a problem with the teacher, I always encourage you to have a conversation with the teacher, but always know that I'm there to support you and the teacher. And if you aren't satisfied, if it really continues to bother you, then I'd be glad to join that conversation to support you and to support that teacher.
Two-part question. What's the goal for next year then? What grades would be tested on?
Next year, 3rd through 5th.
3rd through 5th. It's always 3rd
It's going to be through 3rd through 5th.
And then nationwide, is every state rolling it out this way? Every state is doing it this year, and then the next year?
Every state is doing it this year on a field basis, but not every district is taking both English language arts and mathematics. We are fortunate that we're taking both. We are taking English language arts and mathematics with a performance assessment piece which is kind of like where they have to show their thinking and explain things in either English language arts or math. We don't know which. So you'll have the short answer, multiple choice, those kind of the fill in the blanks kinds of questions in both subjects. And then we'll have a little bit more in-depth single problem in either mathematics or English language arts. And the 5th graders will continue to take the science CST for this year.
I understand that the math program, the midterm, comes with manipulatives. I've seen the bats and the cubes and the fractions and everything, but I think some of the teachers don't know about those manipulatives and are using them in the past, and I think it would be really helpful to use manipulatives.
Well, I agree with you. I think it would be very helpful. And I think the question was that the math program, the Envision math program, comes with manipulatives, and that Stacy's concerned that not all the teachers understand about using the math manipulative. A lot of teachers do use math manipulatives, and in the cases where that might be a concern, we as a group of professional educators are going to grow together. With that as our goal, to give everything a foundation in concrete.
How will this shift impact the homework our kids are expected to do? Do you know?
It
Because
will
it will
impact the homework that your children have to do.
Well, the district has the, for kindergarten it's 15 minutes and then 20, it grows. How accurate that is, I don't know, but, I understand like the concepts behind it, but will the timing, the expectations still be the same on how much they should be getting?
No, I think that homework will change as our approach to teaching mathematics changes. I think that there are certain basic tenets for homework that we will always seek to adhere to. For instance, homework should not be something that introduces a new concept. Homework should not be something that addresses a concept that they're grappling with. Homework should be used to reinforce concepts that they can practice independently. That's the value of homework. So that shouldn't change unless that's not the case. But we will be aligning our homework to the work we're doing in class.
Teachers have to have a relationship in order for kids to get, the maximum.
I agree.
education. And I know for me, I'm one of those parents that I want to have hands-on, but I also need that knowledge. So for Common Core, is there something that parents are going to receive to educate us? So when the kids do go home, we have that type of,
We can put something together like a kid, parent-friendly version of the Common Core.
So, when they start teaching in the classroom, they're gonna visit each teacher and make sure they're teaching the way you want them to teach it?
Yes, little by little.
Are you gonna have a conversation with that teacher?
Well, see, the thing is,
How is that gonna?
I can be confrontational. I always believe as a human being, I believe that just as important as what I believe to be the objective assessment of a person, you have to look at how that person sees themselves. That's how I taught. I tried to meet the child where they were and bring them forward. I try to meet a teacher where they are and bring them forward. Now, if I'm going to go like this, I'm not going to win them. So I have to do it gradually, and I have to do it slowly, and I have to engage them in frank conversations. And I have to get them used to who I am. I wish I could do away with evaluation altogether, because it's beside the point. What we need to do is move forward as colleagues. So I am not going to be heavy-handed. I think my boss wants me to be heavier-handed. I'm not going to be heavier-handed. but I'm going to have frank conversations. And when they get to know me, some of you I've had frank conversations with. I've said, you may not like this, but you need to stop doing what you're doing at home because you're enabling your child. As a kindergarten teacher, I had so many parents in tears because I would say, this is your fault. This is your fault, and you need to stop it. So I will have those conversations as they get to know who I am. Yes, I will. I won't have it officially, like, unless there's no growth. Then I will have it officially, and it could lead to discipline. I just don't start with that. Any other questions? Would you pass out some of these, please? And this is just what the 8 standards of mathematical practice are, and then it goes into my favorite 2, which are make sense of and persevere in solving problems, and construct viable arguments and critique the reasoning of others. Numbers 1 and 3. Those are the most wonderful things. Come down the road.
This is from 3rd through 5th?
Well, this is K through 5, and I'm sure K through 12, but
Based on your level. Based on.
yes, based on their level.
Right.
Based on their level. We're not going to be teaching this in explicitness to kindergartners. We're going to be exposing them in different words. Oh, stick with it. You can do it. You just have to stick with it. This is what we do. We're willing to work hard when we don't understand something. We're going to talk to our friends when we don't understand something. We're going to keep with it. Right? And, to do it in an age-appropriate way that's going to get the message across.
I had went to one of these Common Core meetings for the LA Unified, right? Before they school. And one of the things that the one that was talking, I don't know her name, but she said that if your kid is in 3rd grade, that perhaps that math that is taught in that grade, if they go to 4th grade, it would be on that level of 3rd grade. Does that make sense what I'm saying? Like, it would be like almost repeating.
They are rearranging when different topics are taught in mathematics. So perhaps that's what they were saying. Something that you had that your children had been exposed to in the 3rd grade under the old system, they'll be exposed to again because they've repositioned it into the 4th grade. But when you also have the paradigm shift of just skittering over the top like a stone being thrown on the water versus going deep, then your child may see it again next year because it's positioned in the following grade in Common Core, but they're going to go deep. So it's not going to be just repeating.
I came in late, but did all the teachers do this too?
I had all the teachers do that. And they were uncomfortable. There were uncomfortable moments for them. Especially I had them start out working on their own. And then working with pairs or small groups, and then we talked about it.
And that was the 6th grade, right?
That was a 6th grade example. Now, I'll end with just one idea. There are so many exciting ideas about math, but one idea is that we might change the way we formulate our lessons. The way I did it, I didn't teach you up front about inside angles of triangles and so forth. I let you do it yourself. Then, in a math classroom, I might have different people who are at varying levels of success with this stand up and explain their reasoning. How did they do this? How did I get this? Well, I knew this was a 90, so I knew this had to be. So, and what that does is allow children to learn from each other. Just like you guys were explaining to each other and it made sense to Billy. Well, a lot of times kids can be peer tutors. Because for the person who is explaining, When you really understand something is when you can explain it. So it helps them, and it helps the person who's getting the illumination. And it does switch off. So a lot of times the explicit teaching is done later in the lesson, once the teacher knows exactly where everybody is. Differentiation is super important, and it always has been, but a lot of times differentiation has ended up being a word and not a practice.